Running medium voltage cables, specifically 34.5 kV cables with 80 square millimeter cross-linked polyethylene insulation, also known as XLPE, in a rigid steel conduit, or RSC, present several considerations. The configuration involves 3 such cables, each housed within its own 100 mm diameter RSC. Crucially, the shield of each XLPE cable is bonded to ground at both ends of the run. It's important to understand the consequences potential for inductive heating given a current of 60 amps in each cable, relevant code provisions, and possible violations associated with this installation. Firstly, let's consider the consequences. The ungrounded shield can lead to increased dielectric stress on the cable insulation. Ungrounded shields allow inductive currents to flow, which can induce voltage stresses on the cable insulation. Secondly, there's the potential for cable failure. High dielectric stress can damage the cable insulation, ultimately leading to failure. Thirdly, induced currents can occur in nearby conductors. The inductive currents flowing on the cable shield can induce currents in nearby conductors such as metal enclosures or other cables. Considering inductive heating with a current of 60 amps in each cable, inductive heating is unlikely to be a significant issue for 80 square millimeter XLPE cables in a 100 mm RSC. However, a detailed thermal analysis is recommended to verify that the operating temperatures remain within acceptable limits. This analysis should consider factors such as ambient temperature, soil thermal resistivity if the conduits are buried, and the cable's thermal properties. Regarding code provisions, the National Electrical Code, or NEC, is a primary reference. Article 300.32 requires that the metal sheath of a shielded cable be grounded. This grounding is essential for safety and proper operation. IEE 1584-2018, the IEE Guide for Grounding of Industrial and Commercial Power Systems, is another important standard. Section 6.13 recommends grounding the shield of shielded cables at both ends to mitigate inductive heating and ensure personnel safety. Based on the described installation, there is a potential violation of the NEC requirement for grounding the shield of the XLPE cable. The NEC mandates grounding to prevent voltage buildup and ensure a safe path for fault currents. Now, let's discuss recommendations to address these potential issues. Firstly, grounding the cable shield at both ends of the feeder is crucial. This can be achieved by using a ground wire or ground strap connected to the cable shield at each end and bonded to the substation ground grid or building grounding system. The ground conductors should be sized appropriately based on the fault current available. Secondly, additional measures to mitigate inductive heating can be considered if necessary. Installing magnetic cores around the cables can help reduce magnetic fields and inductive heating. Phase balancing transformers can help distribute current evenly among the phases, reducing circulating currents in the shields. Conducting a thorough thermal analysis is essential to determine if these additional measures are necessary. This analysis should consider worst-case operating conditions and ensure that cable temperatures remain within the specified limits. Other considerations include ensuring proper bonding techniques. Use appropriate bonding hardware and techniques to ensure a low impedance connection between the cable shield and the grounding system. Regularly inspect the grounding connections to ensure they remain intact and effective. Address any corrosion or damage promptly. When selecting cables, consider using low reactance cables, which are designed to minimize inductive heating. These cables typically have a reduced spacing between the conductors and shield. In summary, while a 60 amp current in 80 square millimeter XLPE cables within 100 mm RSC is unlikely to cause significant inductive heating, the absence of proper shield grounding poses risks. It is critical to adhere to NEC and IEE standards, ensuring the cable shield is grounded at both ends to prevent dielectric stress, potential cable failure, and induced currents in nearby conductors. A detailed thermal analysis, proper bonding techniques, and regular inspections further enhance the safety and reliability of the installation. If the analysis reveals high operating temperatures, consider implementing additional measures to mitigate inductive heating, such as installing magnetic cores or using phase balancing transformers.